Hello, welcome to our. Are you sad? Are you hurt? Are you lost? Are you lonely? Worry no more. You are at the right channel. Welcome to Exclusive!
Hello mga ka-ex! Welcome back! Now for our video lesson, we are going to solve equation transformable to quadratic equations, including rational algebraic equation. Given our first example, negative 3 over y plus y plus 5 all over 2 is equal to 3. We are going to solve for its roots. Before we can solve for its roots, we need to make this equation into its standard form. To make this equation into standard form, we are going to identify first our LCM, or our least common multiple. By checking its denominator, our denominators are y and 2. So our LCM is 2y. So we are going to multiply both sides of our equation by 2y. So we can multiply now our LCM to the left side. So 2y times negative 3 over y, that is 2y times negative 3 over y. Next is 2y times y plus 5 over 2, that is 2y times y plus 5 all over 2 is equal to 6y, since we can multiply 3 times 2y. Now, in our left side, we can cancel common terms. In our first term, we can cancel y. On the second term, we can cancel 2. Now, we can multiply 2 times negative 3, that is negative 6, plus y times y, that is y squared, and y times 5, that is 5y, is equal to 6y. Remember that in our right side of our equation, it must be equal to 0. To make 6y be equal to 0, we are going to subtract both sides by 6y. So 6y minus 6y, that is 0. Now, on our left side, there are common terms that we can combine. We have 5y minus 6y. So our result is negative 6 plus y squared. Next is 5y minus 6y, that is negative y, is equal to 0. Remember that in standard form, it is ax squared plus bx plus c is equal to 0. We are going to start with our highest degree, followed by the linear term and the constant term. So by rearranging this equation, we are going to start with y squared, followed by minus y, and lastly is minus 6 is equal to 0. And this is now our standard form of our quadratic equation. Now, let us solve for the roots of y squared minus y minus 6 is equal to 0. We may use factoring in solving for its roots. And the pattern that we can use is y plus and y minus. Now let us think of two numbers that if we're going to multiply, the result is negative 6. And if we're going to add, the result is negative 1. And those two numbers are negative 3 and positive 2. Now using zero product property, we can equate these two factors into y plus 2 is equal to 0 and y minus 3 is equal to 0. Now to solve for the value of y here, we need to place positive 2 to the other side, and to do that, we are going to subtract both sides by negative 2. So positive 2 minus 2, that is 0, and the remaining term is y, So 0 minus 2, that is negative 2. Now for y minus 3 is equal to 0, we need to transfer negative 3 to the other side. And to do that, we are going to add both sides by 3. So negative 3 plus 3, that is 0. And the remaining term is y is equal to 0 plus 3. So that is 3. And our roots of our equation is negative 2 and positive 3. For our second example, we need to solve for the roots of x over x plus 1 plus 4 over x plus 2 is equal to negative 4 over the product of x plus 1 plus x sub 2. Now, to solve for its roots, we need first to make this equation into its standard form. To do that, we need first to identify our LCM. As you can see, our denominators are x plus 1, we have x plus 2, and the product of x plus 1 and x plus 2. So our LCM is the product of x plus 1 and x plus 2. So we are going to multiply both sides with our LCM. Now we can multiply our LCM to this binomial. So our LCM times x over x plus 1, that is the product of x plus 1 and x plus 2, times x over x plus 1, plus, we can distribute our LCM to the second term, and that is the product of x plus 1 and x plus 2 times 4 over x plus 2 is equal to, as you can see here on the right side, we can cancel common terms. We can cancel the product of x plus 1 and x plus 2 and our LCM. And the remaining term is negative 4. Now, to lessen the terms on the left side of our equation, we can cancel common terms. On the first term, we can cancel x plus 1. On the second term, we can cancel x plus 2. So now we can multiply x times x plus 2, so that is x times x plus 2, and 4 times x plus 1, so that is 4 times x plus 1 is equal to negative 4. So using distributive property, we can multiply now. X times x, that is x squared. Next is x times positive 2. We have positive 2x. And we can also have 4 times 4x, so that is 4x. And 4 times positive 1, that is positive 4, is equal to negative 4. As you can see, there are common terms. We can combine 2x and positive 4. As a result, we have x squared plus 6x plus 4 is equal to negative 4. Remember, in our standard form, our right side must be equal to 0. To make negative 4 be equal to 0, we are going to add both sides by 4. So negative 4 plus 4, that is 0. And we can combine now 4 plus 4, so we have x squared plus 6x. Next is 4 plus 4. The result is 8, is equal to 0. And this is now our standard form of our equation. Let us solve for the roots of our equation. Our equation is x squared plus 6x plus 8 is equal to 0. Let us use factoring in solving for its roots. And our pattern is x plus and x plus. Now, we need to think of two numbers that if we're going to multiply, the result is 8, and if we're going to add, the result is 6. So those numbers are positive 4 and positive 2. Now, using zero product property, we can equate these two factors into x plus 4 is equal to 0 and x plus 2 is equal to 0. Solving for the value of x here, we can transfer positive 4 to the other side. To do that, we are going to subtract both sides by 4. So 4 minus 4, that is 0, and that leaves x is equal to 0 minus 4, that is negative 4. Now on the other side, we can transfer positive 2 to the other side of the equation. To do that, we can subtract both sides by 2. So 2 minus 2, that is 0, and that leaves us x is equal to 0 minus 2, that is negative 2. So our roots are negative 4 and negative 2.